This video series is educational in nature rather than advisory. It is always important to consult with your financial advisor before investing. Position Sizing Technologies. Position sizing is a trademark of Position Sizing Technologies. Dr. Van Tharp's Secrets to Profits, the Position Sizing Workshop. This workshop is about position sizing, and it covers strategies that control how much you should invest in any investment or trade throughout its duration. It's the key to meeting your objectives in the market. Tape 3, Optimal Position Sizing. Now again, Dr. Van Tharp.
So today we're going to talk about more advanced position sizing strategies. If you can remember from the first two tapes, tape 1 we talked about R multiples, we talked about expectancy, and we played a game so you got a feeling for how position sizing or how much made so much difference in what you did. Your objectives in position sizing made all the difference in the world in how well you performed in the game. And we also covered the importance of anti-martingale strategies, because anti-martingale strategies are strategies which increase position sizing as your equity goes up. And these are the only ones that work. Now then on tape 2, you saw specific examples of how this is applied to real-world recommendations. And when we risked 1% in a series of trades, over a 15-month period, you returned 55%. When that was raised to 2%, it returned 111%. And you also saw that 1% with 4 scale ends, that particular kind of strategy, returned 160% in that period of time. So on this tape, we're going to go into advantages. We're going to explore the relationship between your stop and position sizing. You're going to learn the advantages of wide stops and the disadvantages, and you're going to learn the advantages of tight stops and the disadvantages, and how to use all of that with position sizing. You're also going to get some guidelines for how to use percent risk, which is probably the most commonly used anti-martingale strategy. And we're going to talk about optimal bet size, what that really means, and how to apply it on this material. So let's look at position sizing and how it changes as a function of one stop. So here's an example of how position sizing changes as the stop decreases. Here's an example of Yahoo in December 1999. If you look at position for point 1 there, there's a breakout, and that's where you'd buy. And you could have a stop at point A, which is only 3 points away. Now, if you were to risk, say, $600 on this position, say you had a $60,000 account and you wanted to risk 1%, that would be $600. So if you were to risk $600 on this position, with a 3-point stop, you'd divide 3 points into $600, and you'd be buying 200 shares. So now, if you go to position 2, here's a different breakout. It's another breakout on the same chart. But here, there's 2 possible positions. At A, you could have about a 2-point stop, which is close to the low of the day. At B, you could have about a 10-point stop. Now, again, if your risk is $600, with a 2-point stop, you'd be buying 300 shares. $2 into $600 is 300 shares. With a 10-point stop, you'd only be buying 60 shares. So 3-point stop gives you 200 shares, 2-point stop, 300 shares, 10-point stop, only 60 shares. So let's look at some of the advantages of a tight stop. Examples of a tight stop would be 5%, a real close low to what we were doing, or maybe just a $1 or $2 stop. With these kind of tight stops, it's easy to get a large R multiple gain. So it's 1 R is only $1, so a $10 gain is 10 R. The second real advantage of tight stops is that 1R is very small. So you want to have 1R losses that are real small, and tight stops give you 1R losses that are very small. So let's look at how a tight stop is going to work for you. Here we get a breakout at point 1. Again, this is the same point I showed earlier. It's where the chart breaks out quite sharply at point 1. That's where you'd buy. Your stop would be 3 points away at point A. Again, if you risk $600, you'd be buying 200 shares. So now look, on that chart it goes all the way up to close to $140 at point B. That's in 20 days, and that's 37 points in 20 days. Your 3-point stop, so 1R was 3 points, gives you a 12.3R gain. And within a month, Yahoo hit $250, which would give you about a 50R multiple gain. So that's what happens when you have a tight stop. And there's the example where you can see point A is where it moved to 137. And then look how much farther and how much faster it takes for Yahoo moving up to 250. If you'd have a trailing stop, you'd have been out actually at about 188. And that's important because Yahoo is probably about $60 a share today. So let's look at some of the disadvantages of a tight stop. First, you're risking, you want to keep your R multiples as small as possible, 1R or less. But because it's small, you risk the potential of the market getting away from you and having losses that are bigger than 1R. Second, because it's tight, you're going to be stopped out quite often, and you're going to tend to have more losers than gains. The next thing is you're going to use up account value really fast, because a 5% stop, for example, is going to require that you use up 20R worth of account value to buy the stock. You're only risking 5%, but the amount of stock you buy is going to be 20R. Whereas, say, a 25% stop, your risk is like 1/4 of the value of the stock, so you're only using up 4R to buy the stock. So buying 200 shares of Yahoo at 93, in our example, is going to cost you $18,600. If it represents 1% of a $60,000 portfolio, that's $600, you're going to use up about 1/3 of the account just buying that one stock, that one position. So now let's look at wide stops. So let's look at the advantages. And wide stops would be examples like the 25% trailing stop. Or if you looked at the daily range of prices and you maybe multiplied that times 3, we call that a 3 times volatility stop, that's a pretty wide stop. And so a stock that maybe is moving 5 to 10 points a day, you'd have 15 to 30 points for your stop before you got out. So these particular kinds of stops allow you to stay in your position a long time. They don't use up very much capital per position. Like the 25% stop just uses up 4 times that value in capital. You'll be correct about more trades because you don't get stopped out very quickly, so that the position has time to move in your favor. And there's very little chance of a large R multiple loss. 1R is probably going to be your maximum loss when you use a wide stop. It's not going to get away from you very much. And your average loss actually with a wide stop is usually about 1/2 R. So let's look at an example of position sizing with a large initial stop. Here's an example again of Yahoo in December 1999. Position 1, point 1, shows a breakout where you get in on a new high from a breakout. And your stop would be at A, which is about $10 away. So when the stock moves up to the top of the chart on here, it's at 137. And that's 20 points. Your stop was 10, so that's about a 2R gain. But that was a 12R gain when we had the tight stop. And then when the stock moves to 250 in another month, that only gives you about a 13R gain as opposed to a 52R gain when we had the tight stop. But again, you're not going to be whipsawed. You're not going to get, you're likely to stay in that position and be able to ride it to the top. But there are disadvantages to a wide stop. 1R is quite big. You know, it could be 50 points on a $200 stock. The large R multiple gains usually take a long time to occur. If you have 50 points on a stop, that means a 10R, it's going to move 500 points. That might take 10 years. And while you're able to, in the case of Yahoo, we got a 13R gain. We got the 52R gain with a tight stop. That 52R gain might be just impossible to get with a wide stop. Or it might take years and years and years with many stock splits and all of that sort of thing. So how can we capitalize on the advantages of having the fact that the market moves all over the place, but we'd like maybe tight stops? So let's look at this example again. You could put that stop at point A in Yahoo, which is only 2 points away, and that gives you the potential of the 12R gain at 137 and the 52R gain later on. But risking $600 here means you buy $300 shares, and if the stock went against you down to that gap, that would be a 5R loss. And it could, in today's market, it could do that quite easily. So if you look at the same stock, it has a daily range in prices, a daily volatility of about $8 a share. And so we're going to position size based on that daily volatility. So if we divide that $600 risk by $8, that gives us 75. So we only buy 75 shares. Okay, so what's the difference when you do it this way, when you use volatility position sizing? You still have that stop $2 away. So 1R is still very tight at $2. You still have the potential for that 12R gain when it moves to 137, and the huge R multiple gain in a couple of months when it moves to 250. Those potentials are all still there, and you'll still do that. But you still have only about a fourth of the exposure here. You have $8,000 worth of stock instead of the $35,000 worth of stock that you would have had if you'd only based it on the $2 position sizing. So let's look at some guidelines that you can use when you're using percent risk position sizing. Say you're a beginner, you haven't done any of this before, you're just playing with the markets, and you have enough material from this tape series to begin to start trading. But I'd recommend that you start very, very small, using risks of maybe 1/4 of a percentage of your account to maybe a half. So if you've got a $100,000 account, you're risking $250 to $500 per position. So, and with tight stops, if you're using like the dollar or two, you're only going to risk maybe 1/10 of a percentage. So maybe $100 on that $100,000 account. Once you've used this and you've proven to yourself that you can make money, then you can move up. You can use maybe 0.5% to as much as 2% risk. Or you can consider using 0.5% or 1% and using the scaling in technique that we showed you on the last tape and that I'm going to talk more about later. Or you can, if you use tight stops like we talked about, you can consider using 1/4 to 1% risk now, or using volatility position sizing. So these are some guidelines you can use to really apply this to the markets. So now let's talk about optimal rates of return and what you can do. And first I want to talk about techniques that you should avoid, because there are a lot of myths about optimal bet sizing and how to do it, and there's certain techniques you really should avoid. I want to talk about what optimal really means, and I want to talk about some useful techniques that you can use to achieve these optimal rates of return. So let's take a look at some of the techniques that you shouldn't be using. One is an old gambler's criteria called the Kelly technique. The Kelly criteria basically depends on just having a one percentage that win, you win maybe 50% of the time, you lose 50% of the time. When you win twice as much. It requires that kind of distribution. So it's not very useful for the stock market anyway. You could average all your R multiples for the winners and all your R multiples for the losers and figure that out. But I strongly recommend that you avoid that because the risk levels are way too high. Ralph Vince has popularized a technique called optimal F. And to me, optimal F means kind of optimal gray hair. If you do that and you keep going with optimal F, you're going to have huge drawdowns, and you really don't want to do that. And lastly, there's a new book out on what's called fixed ratio trading. And while there might be some real advantages to that, I find that they're recommending and talking about risk rates of 10, 20%. And until I get away from that mentality, I'd avoid the suggestions that are given there as well. So let's take a look at what works. But first, before we cover what works, we have to really understand what optimal means. And there are a number of ways that you could define what's optimal depending on what's really optimal for you. So optimal can mean having the highest average ending equity after so many trades. So if you're going to make, we played the marble game, you had 50 trades. So what's the risk percentage that's going to give you the highest average ending equity? That could be one way that you define it. Now, you could also define your optimal in terms of ruin. You don't want to have your account go down by more than 20%, say. So what is the percentage that gives you the highest probability of not having a 20% ruin? That might be another way of defining what's optimal, depending on your own psychology and how you feel about it. The third might be you have some preset criteria. You'd like to double your money over the 50 trials or 50 trades. What's the rate, the optimal bet size to get, or the optimal risk to give you that rate of return? And lastly, you might want to look at something that gives you the highest difference between the goal probability and the ruin probability. So let's take a look at that now. So this is the R multiple distribution in the game in our first tape. We had 10 1R winners, 6 2R winners, 2 5R winners, and 1 10R winner. We also had 20 1R losers, 5 2R losers, and 1 5R loser. When you're determining optimal bet size, you've got to know your R multiple distribution. So we plugged this into a formula we have that requires you to use some very advanced math. It requires a log normal distribution, and I looked at all kinds of probabilities that ran from 0.5% to up to in 0.5% increments to 20%. 20%, you'd go bankrupt as soon as you hit a 5R loser. So, and I looked at all the numbers that are optimal at some level. So if you're looking at the highest average ending equity, this considers that over many, many samples, you might go bankrupt on most of them, but in some set of samples, you might get all 10R winners. And in that particular set, if you risk the most, it would create a huge advantage towards risking a lot of money on the average. So it turns out that the highest average ending equity is very, very close to the number that will cause you to go bankrupt, which is the 20%. So I measured it in 0.5% increments. So if you look at the chart, it shows that at 19.5%, your average ending equity is $153,000 from $10,000. But it's not the optimal unless that's your only criteria. So let's look at the next criteria. Let's say our definition of ruin is a 50% drawdown. We started with 10 trials, and if after 20 trials or 50 trials, we're down by 50%, we call that ruin. So we want to avoid that at all no matter what we do. So if you look at the chart, it shows that the optimal risk level here, well, both for 0.5% and for 1% was 0. So we'll pick the highest number that gives us 0, and that's a 1% risk. So based on that definition now, we have one optimal measure that's 19.5, and now we have another optimal measure that's 1. So let's look at the next one. Now let's suppose that what we'd like in our 50 trades is a gain of 150%. So what's the optimal level that will give us the highest probability of reaching 150% gain? If you look at it, it's right in the middle. It's 8.5%. Gives us a 28.9% chance of risking or of making that 150%. And you notice at 4.5%, it's a little bit less. At 15%, when we double it, it's just a little bit less. And it goes down even more at the high level of 19.5%. So again, a different measure of what's optimal, a different number to answer the question. So the last way that you might want to look at it is the difference between it. So what's the difference between the failure and the gain, or between the gain and the failure? Well, that gives us the optimal level. In this case, it's right there in the middle. It's 4.5%. And the differences are huge. Gives us a number of 16.8% chance of reaching our goal and at the same time not reaching the drawdown goal. So it's a positive number, and it's the highest positive number. At 1%, there's very little chance of reaching the goal because of the differences. At 8.5%, look at the huge difference. It drops from 16.8 to 3.2, and it's negative if you go from 15% on. So as you can see, how you define optimum really makes a big difference in what kind of strategy you pick and what you end up doing. So there's really now some precautions that you need to know about defining optimal risk level. First of all, it depends on the sample of R multiples that you get, that you're looking at. As soon as that R multiple sample changes, what's optimum changes. Also, the mathematical definition that goes in the equation is what we call a log normal distribution. It assumes large numbers of trades, or a very large sample number. In this particular case, we only plugged in 25 trades. So that's not a large number. So it means our estimates are probably off somewhat. So knowing our numbers are off, also, are they statistically different between one number and another? You have to get into things like that. And lastly, as you change your objectives, these percentages are going to change. So we called a 50% drawdown as one optimal level. But if you change that to a 20% drawdown, you're going to get different numbers. We called our gain that was optimal a gain of 50%. But if you change that to 300%, then you'll probably get a different number that's optimal. And lastly, these probabilities only reflect what happens at the end of the number of trades you plug in. So it means after 50 trades or 25 trades, you're going to get these kind of numbers. But it doesn't say that you won't get it. There's not a big chance of getting a big drawdown in the middle someplace. As an example, when we played our game on the first tape, the first marble pulled out was a 5R. So if you risked 19.5%, you'd be down to approximately little bitty equity like that. Now, if you had 10R winners the rest of the way through, you might have a chance of a good recovery, but that doesn't say anything. You've got a huge drawdown right at the beginning without optimal bet size. So it doesn't say anything about what could happen in between. It only says what the results are going to be at the end of the number of trades you plug into the calculation. So hopefully what I've done here is to show you some definitions of what optimal means. And your understanding has to be that you've got to decide what it is you want in your portfolio. What kind of returns do you want? What are your objectives? And what's optimal for you depends very, very much on what you pick for your objectives and what your objectives are. Okay, so let's summarize what you've learned on tape 3. First, you've learned the advantages and the disadvantages of wide and tight stops, and the implications for each for position sizing. Secondly, you've learned about volatility position sizing, because volatility position sizing is a real good alternative when you're using tight stops. You can still have the small 1R stops, but the wide position sizing through volatility gives you much less exposure. You've also learned some guidelines that you can use and apply for yourself for using percent risk and how to do it. So guidelines for when you start out, and also guidelines that you can use when you're getting more experience with this. And all of those will keep you out of trouble. You also understand how to use optimal risk, what it means, and how it relates to your objectives. You've got to define your objectives first. Then through your definition of objectives and what they are, you can define what optimal means, and then you can apply this material.
You should review this tape until you understand these key points. They are critical to comprehending the material that follows. This is the end of tape 3. Please continue with tape 4 of the Position Sizing Workshop, where you will learn how to make high rates of return, how to smooth your equity curve, and how to apply this material to your situation.